Hello everyone. I hope all of you had a fantastic Christmas vacation and that your 2025 is off to a great start. In this video, I will talk about a topic you might find interesting, the Netgear router, especially enabling the Telnet feature, which will again shell on the device, as we will see later. The reason I want to bring this up is that when we purchase a new router, it often comes with outdated firmware pre-installed on the device. And unfortunately, not everyone takes the time to update the firmware to the most recent version right away. This is kind of significant oversight because outdated firmware has a lot of vulnerabilities. I mean, a quick Google search reveals a lot of CVEs tied to the outdated firmware version. What I'm presenting here is not a vulnerability per se, however, it opened the door to further investigation. As you can see here, I'm just presenting some of the famous Netgear router you might find in the market. And here on my terminal, I have a Netgear device that is connected to my machine. You see, this is on this IB 192.168.1.1. And if I do a quick SYN scan, you will see that the Telnet port is filtered or closed. And if I do the same on the UDB, you will see it's open and filtered. What that mean? That mean, of course, I cannot connect to the Telnet, as you can see here. Why is that? Actually, this is how Netgear designed their router. So there is a binary which called PU Telnet enable. Usually it listens either on the TCB or in the UDB port 23. This binary expect the packet, usually known as the magic packet. Once it is received and validated by the Telnet enabled binary, it will open the Telnet, and that means then you can connect and obtain a shell on the device. In the past, there is a lot of research over this packet, how to construct this packet. One it's very famous here on the open word. So if I go here, you would see they list the routers that when they did their research, and those the router that accepted this magic packet. You will find also some codes there. However, the codes there didn't work on the modern one. At least didn't work on my device. But this is how it started. How they figure out the structure of the packet, the secret key, as we will see later. So what is this magic packet? This is what I will introduce first. So let's start with an older version of the Netgear router. So this magic packet contains like 5 components. First, the MD5 hash. We will see how we can calculate it. This is 16 byte. Then we have the MAC address of the device, then the username and the password, and then there is a field which is reserved 40 hex or 64 characters. This is over TCB, and if we want to check over UDB, then it's the same structure. However, you might notice the difference that the password here is up to 21 hex or 33 characters. Actually, there is a discussion on one of the GitHub pages here actually where they found out that, okay, if we increase the length of the password, yeah, we will write on the reserved field, but the bucket still works. That the reason might be that Netgear wanted to increase the length of the password, so that's why they allow until up to 33 character there. And okay, so how we can calculate this, the signature or the MD5 hash. The signature actually is combined from the MAC address, the username, the password, and the reserved field. All of them can concatenate together, and then the MD5 hash is calculated. In the older version, the default password, username and password was Gear Guy and Gear Dog. That was the default at that time. So this is how we get the signature. This is the first step. The second step is that this magic packet is actually encrypted. And in order to do the same, we need to figure out the secret key. Also, during the research I mentioned, they found out one part of the secret key, which is this is at the first one, Enbale, Telnet, Enbale plus, then you need to concatenate the password itself, and then you get the secret key. Regarding the encryption algorithm, they used Blowfish for that. So first you calculate the payload. Now the payload is the signature which we calculated earlier. Again, we add the MAC, the username, the password, and the reserved field. All of this we will use Blowfish to encrypt that using the secret key and the mode ECP. That will allow us to create this magic packet on the older router. However, in the newer version, a little bit like almost the same, but the difference is again the length of the password is increased. It's up to 56 here. I should mention the NCC group, which they did this on one of their paper here, and they see the password here. It's up to 56 characters. So it's longer. That means the user now could create a complex password up to 65 character. This is one difference. The second thing they Netgear change is that now you don't use the plain text password. You have to hash the password first, and they use the SHA-256 for that. So now to calculate the signature, we concatenate the MAC, the username, and then the hash of the password, then the reserved field. All of that we put it to the MD5, and then we get the signature. Regarding the key, again, now we use the same. The first part is the same. However, now we use the hash of the password, the hash SHA-256, with the key in order to get the complete secret key. The encryption algorithm is still the same. It's a Blowfish, but we use now we calculate the payload including the SHA-256 of the password. This will allow us to create the magic packet for the newer version of those router. We will take an example, but before we do that, maybe let me show you the Python script I did in order to construct this bucket and send it to our device here. Maybe we could start here. It's just one script. I could start on the main. At the beginning, I'm just getting the argument from the user. Everything is the default. However, the only required argument is the MAC address. So you need to provide the MAC address of your router if you want to use this script. And of course, if you change the username and the password, then you need to add it as well. Then the next thing, I'm creating an instance of the class payload builder. So this is just will allow me to create now. We want to create a payload, so here we will get the MAC address, the username, and the password. After that, of course, I'm creating the payload. So we calculate the signature here. You see, we obtain the MAC address, the username, and the password. We put them all together, and then I'm using the MD5 function from the hashlib library in order to calculate the MD5 hash. Inside those functions, I'm just cleaning, like for example, for the MAC, I'm removing the colon, replace it with empty, and then also I'm padding, because as we mentioned here, so the sizes are specific. For example, we need to the MAC 16 bytes, so that's why I'm padding with 0 until 16 byte. The same for the username, and the same for the username and the password. I'm padding until the correct links of the specific field. And that's how we calculate the signature here. I do the same for the username, password, and once we get all of that here, we start the encryption. So this is the second step, the Blowfish encrypt. Here is something different I did because I needed an implementation of a Blowfish. I tried to use the one from the Python, but however, it didn't give me the correct output. I guess the reason for that is in the Python one, I needed to truncate the key. This is was not the case for the Blowfish implementation in C. So that's why I search, and there is a C implementation for a Blowfish. You see it's old, but it works fine. So what I did, I took this implementation of a Blowfish, I made it as a static library, and then I will use it in my Python code. Usually this is a trick I do if I don't want to use two like the C and the Python. So here I convert it to a static library, and I use it. What I mean by that, you will see here at the top, for example. Yeah, exactly here. So that's how I made now the C implementation as static library, and then I call it here. So lib Blowfish, this is the variable which will use the C implementation of the Blowfish. So here at the beginning, again, I'm calculating the hash, I'm calculating the key, and then the payload. And after that, here, I'm starting like one of the first step usually when you use the Blowfish is you initialize everything there, and once it's ready, I use the encryption. This is the second function, Blowfish encryption, and here we encrypt each block there. If you want to go more details, you could have a look on the implementation of Blowfish, but this function will calculate or will encrypt, let's say, the payload using the Blowfish implementation with the secret key here. Once the payload is ready, at the end I'm sending over UDP, because in my case my router is listening on over the UDP, so I'm just creating a simple UDP socket and I'm sending the packet there. So this is the Python implementation. And as I mentioned, maybe a little bit about my target. My target is Nighthawk RAX30. It's an version 10570. It's an older version. I kept it the same when I ported. This is the MAC address, the IP address, and the Telnet enabled is listening on the UDP. We will see later that usually you have two accounts on the Telnet router. One is the user, which is more restricted, and then the one is the admin password, which I'm using now to enable the Telnet. Okay, so now let's see the practical example, what we need to do in order to enable the Telnet on the device connected to my machine. Let me go here back to the Python. I will use the terminal. One thing I should mention, I will use the Python PyCharm here in this case because I am inside the virtual environment, because I need to use the crypto library based on what operating system you are using. Either you have to use a virtual environment to install the crypto library inside the virtual environment, or if your operating system allows you to install it system-wide, then that will not be a problem. But in my case, I'm using Kali. Kali now somehow doesn't allow or prefer, like all the libraries are stored within a virtual environment, so you don't break the system. So here I am inside this virtual environment. I already have the Netgear, but what I will do first, I need to get the C implementation of the as you can see here, of the Blowfish library. So get clone, and then I will get it here. Let's go inside the Blowfish, and I want to compile it, as we said, as a shared object. So this is the command you can do. So again, I'm using the GCC with some flags in order to compile it as a shared object. Now, if I list you, you see it here, it's ready. I have it on my device. The second step in your case, you need, of course, to get clone the script from my GitHub. I will not do it here because I have it already in my machine. So now let's jump to the Netgear, and you see here it's the enabled function. What I need, because I'm using the default for everything, so now we are in this slide, I'm using the default for everything. So the only thing I need to do is supply the MAC address of my router. So let's run this command. This is the MAC address of my router, and everything is the same. Let's hit enter. You see it will tell you that it calculated the signature, calculated the payload, the Blowfish, and this is the magic packet, which is sent to the device over a UDP and this port. Let's make sure now we have it. So what I will go back here, let's go Telnet and 192.168.1.1. and it asks me for username. I will get user and user. And suddenly we are inside the shell. If I type ID, I will not get it because, as I mentioned at the beginning of the video, this is not a standard Linux operating system shell. So I need to type help. And then you see that I have restricted shell. I only allow to use those few commands. If I logged in as admin user, you will see that there are more commands I can use, but it's not the same as the standard. Like if I go to here, I can use any command I want because this is standard there. My next video will be, can we break out from this shell? And the answer is yes, but that I will leave it for the next video. I will show you how we can privilege escalation and escape from the shell. I hope you enjoyed this video. As I said, good luck. I hope this year will be great for everyone. Thank you very much, and bye-bye.